All right, so now let's talk about the actual project that we're going to be building inside of KiCad. What is the actual PCB that we're designing and what is it used for? Well, for an example project, we're going to stick with something very simple. Let's say, for instance, that we have something like this. This is a little USB battery bank that I received when I joined on as an instructor at Florida Poly. It's very nifty, right? It has your standard USB output where we can connect any kind of USB device, say a phone, to charge it. My problem with this, however, is that it's a really low capacity battery bank, and also it doesn't use the Type C connector that I typically use for my phone charger. So I want to repurpose this. I want to create a PCB that instead allows me to turn this into a flashlight. I want it to have a USB connector that plugs in right here, and then I want it to have an LED that will actually produce light, so I can use this as a flashlight. We're going to sort of go through how we can build a really simple printed circuit board that we can then have manufactured and connect to this or any other USB battery bank to convert it into a flashlight. So let's create our project to start this design. When you open KiCad and you're at your blank main menu here, and when I say blank, I mean blank as in the project files panel over here on the left has absolutely nothing in it. We'll want to first click on File and then New Project. And now KiCad will ask you, where do you want to put your project? We can create a new project. I'm going to make one on my desktop and I will just call it USB underscore flashlight. And you'll see that I do have this little box checked in the menu that says create a new folder for the project. So I'm not even going to make a new folder on my desktop. It'll automatically do that for me since I have this box checked. So once I click save, you'll see first that our project, the title bar of our window has changed to be the name of our project, USB underscore flashlight, and we now have those two default files that I mentioned in the previous video, which are your PCB layout file and your schematic file. The layout file has the suffix .kicad underscore PCB, and the schematic file has .kicad underscore SCH for schematic. We can confirm that it placed the project in the right place by going to our desktop in File Explorer, and you'll see that it did in fact create a new folder with the same name that I gave it, USB flashlight, and inside of that we have these three files. Now, why do we have three files here when we only have the two files showing up inside of our panel here? Well, the third file is the project file. That's kind of the one that KiCad uses to group all of the related project files together. So if we were to close out of KiCad here and then go back to our folder and then double click on the project file, it'll automatically know that all of the files, all of the schematic and layout files that were automatically generated as part of this project are associated with each other. So we won't have to manually open them up one at a time. We can just open up the project file, the KiCad underscore PRO file, and it'll automatically give us access to our schematic and our layout. Now, you'll also see that whenever I closed out of KiCad, it generated a couple more files. For instance, it made a folder with USB flashlight backups. KiCad has a feature that automatically saves your progress in your designs every 30 seconds, I think, by default. So if something happens, say your computer crashes, you won't lose too much of your progress. However, I still recommend that after every major change that you make to your board, you just hit Control S really quick to save everything. Sometimes the autosave feature doesn't work perfectly and you wind up losing some of your progress, which is never fun, especially when you're working on a more complex design. So now that we know what our project directory looks like, let's start by editing the schematic. You can either click the schematic editor button right up here, or you can double click on the KiCad underscore SCH file that was generated in this project files menu. And your schematic should look something like this. If the colors of your document are different, that's completely fine. That's just because KiCad has a bunch of different themes, and we can change these to sort of make them easier on the eyes or make them more, visually appealing to you. I like this one just because it's not a bright, searing white light that, sometimes gives me a headache whenever I'm working on these late at night. So this is our blank schematic file. Before we actually start placing our circuit elements on here, our actual resistors, LEDs, connectors, so on and so forth, let's talk about setting this up so that it's really easily readable and interpretable by other people. The very first thing we'll want to do is zoom in by scrolling on this box in the bottom right hand corner. You'll see that most of it is blank. This top box, the largest one, is completely empty. We have a sheet line that just has a slash in it. We have the file name. We have a blank title bar, the software that it was made in, size of the document, so on and so forth. We want to fill this in. It is very good practice to always fill in these different fields so that whoever comes along later and is looking at this schematic knows exactly who made the file, what version of KiCad it was made in, and maybe what its purpose was. So what we can do to edit this is just double click on any of the fields in this box, and you should see the page settings menu open up. Inside of that menu, we'll fill out all of the relevant fields. For the issue date, I like this to be the last date that I worked on a schematic. Different companies have different conventions. Some people prefer to include the date that the project was first created, but in this instance, those two will be the same thing. So I'll go ahead and enter today's date, which is March 19th. KiCad has this little feature that allows you to rapidly just import the current date into that field by clicking on this little triple arrow button right here. For a revision number, you always want to track what the current revision of your board is, so that say you have a very old version of a board and a very new version, but they look identical, you want to be able to tell very quickly which one is the old and which one's the new, so that if there was some critical failure with the old version, you don't accidentally use that one and wind up, causing some damage or maybe frying the board. So we can just call it V1. Again, different companies have different conventions for this. Some people will include decimals, just like in software for major and minor changes. I'm just going to call it V1.0 here for version 1.0. The title, I'm going to call this USB flashlight. Company, if you work at a company where you want to show that this project was created in relation to that company, you can enter the name here. I'm going to enter Florida Polytechnic University. And then another good practice that isn't strictly required, but I highly recommend it to you, and I'm sure future employers will appreciate this as well, is including an author field. Basically tell everyone that it was you who created the schematic, or you who last worked on. So I'm going to type author, and then my name, Kevin Rack2. Once we click OK, you'll see that all of our fields automatically updated to include all of the data we entered. There are some other features in that menu. If we reopen it by double clicking again, there are a few other features that we might want to note. For instance, if we want to make the schematic bigger, we can do that by clicking on this size drop down right here and changing the size. I'm going to leave it at the standard default A4, but you can change that if you need to, or if you want to change it so that it's vertically oriented rather than laid out horizontally, you can change this orientation drop down from landscape to portrait. But again, landscape is the default. I'm going to use that. Now, we can actually start creating our circuit schematic. To do that, we want to start placing the components that we'll need. For our USB flashlight, we will need a USB connector to plug into the USB port right here. And then we'll need an LED to actually produce light. We will also need a resistor to limit the amount of current going to that LED so that we don't burn out the LED or draw too much power from the battery bank and fry it. If you have taken circuits 1, you already know the principle behind this, that increasing the resistance in a circuit decreases the total amount of current that's allowed to flow through it. If you haven't gotten that far yet, you will get to it eventually. That is one of the fundamentals of electrical engineering. But for now, all we need to do is find those components in KiCad and place them on our schematic right here. To do that, we click on this little button up in the top right that if you hover over it, it says Place Symbols. There are also useful keyboard shortcuts for just about everything you'd want to do in KiCad on a regular basis. For instance, placing symbols can be done by pressing the capital letter A key on your keyboard. And it might take a moment to load up the default libraries in KiCad, but then once it does, you should see this menu right here. You'll see that in the title bar, it should say something like 22,470 items loaded. That means that KiCad, without having to install any plugins or third-party software, already includes 22,470 symbols and part files that we can use without having to manually draw them or import them from a manufacturer, which that's fantastic for us because it saves a whole lot of time whenever we're designing a very simple board like this. Let's first find our USB connector. This is a USB Type A female port, so we need a USB Type A male plug to fit into that. Let's just search USB and see what comes up. You'll see that it's narrowed down our searches to this connector category, and we have a whole bunch of different type of USB-A's or USB connectors here. Let's try to find a USB-A male, which we can use this one right here. This is a USB-A connector. It doesn't specify male or female, but that's fine because we can, the pins for this are the same for both male and female connectors. We will choose the actual connector, the physical three-dimensional representation later on whenever we get to creating the layout for our board. So I'm going to double click on that USB-A line, and you'll see that that menu has closed, and now I'm clicking and dragging the symbolic representation of that component. We can use the scroll wheel to zoom in and place this wherever on the schematic that we like. I'm going to start out in the top left right here. You click again to actually drop that component to place it. And then let's place our other components too. Before we actually start drawing any lines or wires, let's just include every single component that we're going to need for this. So the next component we'll need is an LED. I'm going to search for LED and show you all of the different things that come up. There are many different types of LEDs available on the market. It's very easy to get overwhelmed by the sheer number of options that are available in KiCad's symbol menu here. But I'm going to say that we want to use just the very first generic LED symbol, which it's just LED. There's no suffix after it, there's no underscore, anything. So I'm going to double click on that one, and you'll see that I'm now dragging around the LED symbol. I want to flip this so that its cathode, its negative terminal, is facing to the right, just because to keep everything simple, we're going to have current coming from the V-bus line, pin 1 on our USB connector, into the anode, or positive terminal of the LED, and then coming out of it and going to ground. To flip the connector, there are two different ways I can do this. I can press R on the keyboard to rotate it by 90 degrees at a time, or I can just press X to horizontally mirror the component. Lots of different handy little shortcuts here. I'm going to place this on roughly the same line as pin 1, our V-bus pin on the USB connector, and I'll click to drop that. Now, there are tons of little cosmetic customizations you can do here. For instance, it immediately bothers me that the text is not vertically or horizontally aligned with our LED symbol. It's kind of offset to the right. So I'm going to click and drag to select the two lines of text and then drag it to be directly over the LED. So that looks great. Now, the next thing that we need is a resistor. We're not going to worry about the actual resistance value yet. We just know that we'll need a resistor. So I'm going to pick, or I'm going to go back to our place symbols menu, and I'll search for a resistor. Whenever we search for a resistor, we'll see a bunch of different options come up again. There are four different options for symbols that we can use here. We can use the R symbol, which is just this little rectangular box with two lines coming out of it. We can use the 45-degree angle one. There's a smaller version of the same thing. But then you'll also see RUS, R_US, and R_small_US. If you click on those, you'll see it's the squiggle sign that we're more familiar with. The international convention for drawing a resistor is actually the little rectangle, but the more traditionally American symbol is our zigzag line. So just for ease of recognizability, I'm going to use the US symbol. So we're double clicking on R_US. And again, this one starts out vertically oriented. I want to rotate this so that it's horizontal. So I'll just press the R key once. And I clicked and placed that right next to the LED. And now that should be just about all of the components that we need for this circuit. Now, before we actually start connecting things, there's another thing that we need to do here. We need to identify what our ground is. We learned in circuits that every single electronic circuit needs a ground somewhere so that our voltages have a reference. They have a zero value that they can then be related to. We know that our USB connector has a ground pin right here. It also has a shield, which is just the little metal housing that goes around the USB connector. The shield and the ground are usually connected, so both of those are ground for us. Now, there are a couple of different ways for us to connect this ground to every other ground in our circuit, but we tend to gravitate towards one more than the other. The first option is to draw a line from every ground and connect them to each other. For instance, say we wanted to have both the LED and the resistor connected to ground at the same time. I could do this, where I draw a line to the LED, and then I draw another line to the resistor. However, that gets very messy very quickly, and it's also sometimes a little bit hard to tell that all of these things are going to ground whenever you have a whole bunch of crisscrossing lines on your schematic. So what we can do instead, I'm going to press Ctrl-Z to undo those two lines, is I'm going to use a global label. If you go to the little icon directly underneath the place symbols icon, hovering over it will show place power symbols, which you can also access by pressing the P button on your keyboard. There will be a whole bunch of different power symbols in this power dropdown that we can use. Inside of here, there should just be a ground, capital G and D, that if we click on it, it's that very common symbol for ground, which is just a little upside down triangle with a line coming out of it. I'm going to double click on that one. If I place this ground down here next to the shield and ground pins on the USB connector, I can then connect that ground to both of those pins by drawing a very short line to each one of them. There are two different ways that we can start drawing wires in KiCad, which is those lines. We can either click on the Draw Wires button over here, or press the W key, which will automatically start drawing a wire from whichever point you are hovering over. Or, actually three options. you can click on the little circle that's attached to each pin on any component. If you click on that circle, it'll automatically start drawing that wire. I'm going to draw a wire from the shield pin to our ground icon down here. Now we also want to connect our ground pin on the connector to our main ground down here. So I can click on that circle and it'll automatically start drawing a wire. And then I will connect that to the same line, the same pin as the shield right here. Whenever two wires in KiCad have a little dot on them, it means that they are in fact connected to each other. If two wires are crisscrossing, if they intersect but they don't have a dot on them, they're not actually connected to one another. This is universal notation that is used for electrical schematics. So basically, we try to prevent a lot of wires from crisscrossing in our schematics unless we actually intend for them to be connected to each other. So now we have our grounds from our USB connector tied to this global ground. Now, why are we using a global ground here? Why aren't we just connecting our resistor to that ground with a wire? Well, like I said, it gets really messy very quickly if we have a bunch of different wires for ground, because in a more complex circuit, just about every component needs a ground connection somewhere, or most components will. So by the time we're done with our schematic, we'll have ground wires everywhere, and it becomes really hard to read our schematic. So instead, by using this global symbol for ground, I can now just place another of these same ground symbols, either by going back in that same power symbols menu, or by selecting the ground symbol here and copy and pasting with Control C, Control V, and then put the other ground over here. And I'm going to connect this end of my resistor to that ground. So what that did is it's telling KiCad sort of in the background that these two components are connected to the same place, even though on our schematic diagram right here, they are kind of far from each other. There's no direct connection between the two. Because they're using the same global label, that ground symbol, KiCad knows that whenever we actually need to start laying out our circuit board, they're all going to be in the same place. They're all connected to the same electrical network. You'll see exactly what that looks like whenever we get to our layout. For now, let's finish the rest of our circuit. On our USB connector, we have a D plus and a D minus pin. Those are data plus and data minus. That's how a USB cable actually sends data or information over the cable. We don't need to use that since we're only pulling power from the USB connector. We're not actually using it for sending any signals. So we can just tell KiCad that we don't want to use these pins. We want to not connect it to anything. To do that, we can hover over the place where we want to indicate that there's no connection, and then press the Q button on your keyboard. And you'll see a little X place on that location. That's called a no connect or NC symbol, and that does exactly what I said, where it just tells KiCad we don't want any connection to that pin. We want to leave it completely disconnected. It'll solder to the board, but it's not connected to anything else electrically. We'll place another one of those X's, those no connect symbols, on pin 2, our data minus pin right here. So now that we're done placing our no connects, we want to get out of this tool so that we aren't placing any more X's accidentally. To exit out of any of the tools in KiCad, just press Escape, your ESC button on your keyboard. And that will send us back to our regular cursor. You can also always just click on your Select Items button up in the top right to exit out of any one of these options down here. We'll talk about some more of those options later on, but most of them we won't have to use in this case. So now what we want to do is take the voltage that is made available on our USB port, and we want to send it into the LED right here. Specifically, we want to send it into the anode, the positive terminal of our LED, which is always represented by the flat side of the triangle on the LED schematic symbol. To do that, we're just going to draw a wire from VBus pin 1 on our USB connector over to that anode, that flat side of our LED. So I'll click on that circle here and draw a wire over to our LED, and click again, and it'll automatically exit out with that wire being drawn. You'll notice that there are no dots here, and I said earlier that if there's no dot, it means that no two wires are connecting to each other, but that's because these aren't wires. This is a symbol, and the connector is another symbol, so the wire isn't intersecting with another wire. It's not showing you that, two different wires are actually connected. The fact that the circle disappeared on the pin of each one of our components means that this wire is in fact connected to it. So far so good. Now we have current flowing from VBus over to the anode of our LED and then through the LED. We want that current to come out of the LED, go through the resistor, and then go into the ground. So the only connection we have remaining is from the LED to the resistor. So again, we can just draw another wire in the same manner, like so. And this is the complete schematic for our printed circuit board design. Now, are we done? Not by a long shot. We still have the entire layout of our PCB to do. And that's where we actually get to the fun part of deciding where we're going to put each one of our components and then drawing the actual physical connections between each one of them. We'll come back to that in a little bit. But first, we have to talk about actually assigning footprints to each one of these components.